Hi, good afternoon, everyone. So today we are going to take one question from the book Osborne. The question says altruistic players in prisoner's dilemma. Altruistic means beta when you are more concerned about the other player rather than your player or yourself. है ना? So usually to give an example of altruistic preferences, I give the example of a mother. A mother may get more happiness when her child gets food. Her utility increases when the consumption of food of her children increase. So she is getting utility from the consumption of the other individual. So she is altruistic in nature. Similarly, here we are saying that the players are altruistic in nature. तो अब क्वेश्चन को एक बार जरा ध्यान से पढ़ो. The players are altruistic in nature. ठीक है? Read out the question once. What is the question going ahead and saying? Altruistic players in the prisoner's dilemma. Each of the two players have two possible action: quiet and think. So player one can either keep quiet or think. Player two can either keep quiet or think. Each action pair results in player receiving the amount of money equal to the number corresponding to the action pair in part figure 24.1. If player 1 chooses quiet and player 2 chooses think, then player 1 receives nothing, whereas player 2 receives 3. तो देखो जरा कैसा बनाया हमने. Player 1, player 2. क्वाइट चुप रह सकता है या दूसरे के अगेंस्ट बोल सकता है, either quiet or think. Okay, now it is saying that the players are not selfish, rather the preference of each player I is represented by the payoff matrix, where mi is the amount of money received by player I from action profile A, J is action of other player. तो अब उन्होंने क्या बोला कि किसी भी प्लेयर को, any player, he is getting utility from the payoff from the money of the other player. You see this payoff function, देख रहे हो इस payoff function को एक बारी. So the payoff function that we have here now, but that payoff function is this. Okay, this is the payoff of player I. So player I is getting payoff from what money he has, but yeah, whatever payoff he has, but he's also getting payoff और यूटिलिटी फ्रॉम द अदर्स बेनिफिट. दूसरे के बेनिफिट से भी उसका यूटिलिटी बढ़ रहा है. ही इज गेटिंग यूटिलिटी फ्रॉम अदर्स बेनिफिट. ठीक है, वेयर एम आई ए इज द अमाउंट ऑफ मनी रिसीव्ड बाय प्लेयर आई फ्रॉम एक्शन प्रोफाइल ए एंड जे इज द अमाउंट फ्रॉम अदर प्लेयर. सो प्लेयर वंस पे ऑफ फॉर क्वाइट बिकम्स 2 + 2 अल्फा. तो अब क्या हो रहा है ना, ही सेज दैट कंसिडर दिस. So let me give you an example first. पहले एक बारी हम एक basic game ले लेते हैं. So when both players were quiet, जब दोनों चुप थे, they were going ahead and they were getting a payoff of 2. So just think about this before I do this. Just go ahead and compare this. Compare this with the actual prisoner's dilemma game. So in the actual prisoner's dilemma game, when we were talking about the two player 1 के लिए best क्या था? That the other player keeps quiet and he says something against the other player. ये player 1 के लिए best option था, है ना? That the other player keep quiet and he says something against the other player. So when he was thinking and the other player 2 was quiet, he was getting 3 and other player was getting 0. ऐसे ही the worst thing for player 1 was when he was quiet but the other player gave some proof against him. उसमें he was getting 0 and other player was getting 3. In between, the second best was when both of them were quiet, so 2-2. And third best were when both of them were saying against each other, so 1-1. ये एक्चुअल प्रिजनर्स डिलेमा गेम है। अब हमने पे ऑफ को कैसे लिखना है? सो पे ऑफ प्लेयर आई बिकम्स एम आई प्लस अल्फा एम जे। ठीक है, सो नाउ इफ आई वांट टू, क्योंकि आई एम अफेक्टेड बाय द पे ऑफ द अदर प्लेयर ऑल्सो, जो दूसरे को कितना यूटिलिटी मिल रहा है एक्शन से, आई एम अफेक्टेड बाय दैट ऑल्सो. सो नाउ इफ आई वर टू रिक्रिएट दिस मैट्रिक्स, right beta? So what will happen? Quite think, quite think, player 1, player 2. So now it will become mi is 2 plus alpha into 2. So this will become 2 plus 2 alpha. ऐसे ही m दूसरे प्लेयर के लिए, for player 2, this will be payoff of 2 plus alpha payoff of 1. So 2 plus alpha times 2, so 2 plus 2 alpha. यहां पे बनेगा 0 plus 3 alpha, and this will be 3 plus 0 alpha. Are you getting this thing? What the question is saying? So this will become 3 plus 0 alpha. This will become 3 plus 0 alpha. This will become 0 plus 3 alpha. This will become 1 plus 1 alpha, and this will become 1 plus 1 alpha. So your payoff plus alpha times दूसरे का payoff becomes your new payoff. Your payoff plus alpha times दूसरे का payoff becomes your new payoff. ऐसे करके we have written this payoff matrix. Clear? ठीक है. Now read the question. Question is saying formulate the strategic game that models its situation when alpha is equal to 1 and find whether this is prisoner's dilemma or not. So now I will take alpha at 1. So the moment I take alpha at 1, beta, what will become my game? Player 1, quiet, think. Player 2, quiet, think. ये हो जाएगा 2 plus 2, that means 4, comma 4. 3 plus 3 into alpha means 3, comma 3 plus 0 into 1, that means 3. Just put alpha as 1. 3 plus 0, that means 3. 0 plus 3 into 1, that means 3. This will be 2, comma 2. Clear? And find its Nash equilibrium. इसका Nash निकालो. Find Nash equilibrium. So hold this at quiet. Find what is best for second player. So between 4 and 3, 4 is better. Hold this at think and find what is better for the second player. So between 3 and 2, 3 is better. Hold this at quiet and find what is best for first player. So between 4 and 3, 4 is better for the first player. Hold this at think and find what is best for the first player. So between 3 and 2, 3 is better for the first player. So what is coming out to be your Nash beta? Nash equilibrium is coming as quiet, comma quiet. और जब हमने actual prisoner's dilemma किया था, when we did the actual prisoner's dilemma, the Nash equilibrium, it was coming out as Fink, comma Fink. This was coming out as Nash equilibrium. ये वाला. Just putting 2, 2 here. This was coming as Nash. So prisoner's dilemma का property क्या है? What's the property of prisoner's dilemma? The property of prisoner's dilemma was that a better option was available. एक better option available था, that this was available where both of them could have increased their payoff, but this was not Nash. Nash equilibrium ये आया था. This was coming out as Nash. So that is why it is called prisoner's dilemma. Even though a better payoff is available, but when people shift to this payoff, अगर दोनों चुप रहें, they have an incentive to deviate. So although quite will give them both more payoff, दोनों का ही payoff बढ़ रहा था, they have an incentive to deviate, and it is not Nash equilibrium. Right? But in this particular case, we see that quite, which is also giving the maximum payoff, is also coming out as Nash equilibrium. So is this like a prisoner's dilemma game? The answer is no. So this is not prisoner's dilemma. No, it is not prisoner's dilemma. Read out the second part, beta. Find the range of values of alpha for which the resulting game becomes prisoner's dilemma. अब हमें चाहिए that we should go ahead and we should get the resulting game to be prisoner's dilemma. It means that we want this one to be Nash equilibrium. We want Fink to be Nash equilibrium. हमें चाहिए कि ये Nash equilibrium आए. We want Fink to be Nash equilibrium. ठीक है, इतना क्लियर हुआ? We want Fink to be Nash equilibrium. अच्छा, now think about it. When player 1 chooses quite, player 1 quite choose कर रहा है. I want player 2 to choose Fink. I want him to choose Fink. तभी तो ये इससे मैच करेगा एक्चुअल प्रिजनर्स डिलेमा से. सो व्हेन प्लेयर 1 is choosing quite, I want player 2 to choose Fink. That means I want this number 3 plus 0 alpha to be greater than 2 plus 2 alpha. So I want 3 minus 2 to be greater than 2 alpha. 1 greater than 2 alpha. Alpha less than half. Similarly, यहाँ देखो. When player 1 chooses Fink, I want player 2 to choose Fink. So I want him to choose this. इसके ऊपर. So I want that 1 plus 1 alpha should be greater than 3 alpha. ये वाला जो value है, it should be more than this value. So I want that 1 should be greater than 2 alpha. So alpha should be less than half. यहाँ से भी यही आंसर आ रहा है. Now, when player 2 chooses quite, player 2 chooses quite. So I want player 1 to choose Fink. That means I want him to choose this. So I want this value to be greater than this value. So I want 3 plus 0 alpha to be greater than 2 plus 2 alpha. So I want 1 to be greater than 2 alpha. So alpha to be less than half. यहाँ से भी यही आंसर आ रहा है. And when player 2 goes for Fink. So I want player 1 should be choosing the number before comma as Fink. He should be choosing this. तभी तो ये Nash बनेगा. So I want him to choose this over this, player 1, which means that I want him to have 1 plus 1 alpha greater than 3 alpha. That means alpha will be less than half. So from all places, I go ahead and I get the same thing, that alpha should be less than half. Then it will be acting like a prisoner's dilemma. It will act like a prisoner's dilemma. So that's the answer to this question, that alpha should be acting like a less than half. It will be like a prisoner's dilemma game. Is this answer clear to you? Right? So beta बहुत ज़्यादा कुछ नहीं करना है, but you need to be very thorough with the concept of Nash equilibrium.